going to go ahead and get started. So our very first real geometry section, no numbers, all vocabulary. That can be good or bad. Everybody has things that they are their strengths. We definitely have to know the vocabulary in geometry. That is one thing that kids who do not learn the geometry, it's hard for you to be successful. I mean, the vocabulary, it's hard for you to be successful. Because when I use terminology and vocabulary, you have to know what I'm talking about, right? When a question asks you something, if you don't recognize the terminology, then you're not going to be able to answer the question. Billy, did you bring back that worksheet I gave you? All right, so geometry is based on four things. Undefined terms, which we're going to learn about today. Defined terms, which we're going to learn about today. Not all the defined terms, we're going to learn some defined terms today. And then class lists and axioms. So these are statements that we accept as true without having being able to prove that they are. Kind of like, I can't prove that the earth is not flat, but I know it's not flat, right? I know it's here. The geometry people tell us it's true, and we take their word for it. Okay? And then there are theorems, things that we can prove, and we'll learn why those things are true. Once we learn why a theorem is true, we've proven it, then we can use those theorems to prove other things. All right? But we're concentrating on the first two today. Once again, your assignment is in Alex. There's nothing to submit in Canvas for your AWS 1-2, but we will scan and submit these notes to Canvas. So you can use your phone once we're done with notes, scan and submit your notes, and then start your assignment. Cool? Okay. All right, so we'll get to the undefined terms. Undefined terms, there are three in geometry, and we can describe these terms, but we can't really give a provable definition, right? The first is a point. The second is a line. And the third is a plane. Now, you might think that this black dot here is a point, right? Well, it's a black dot, right? That black dot is marking the point P, right? That is the location of the point, but the point is actually not a thing. It's not tangible. Does that make sense? This dot tells us where point P is, but it's not point P. That's the undefinable part. When we see a point, if we have to name a point, we name it by the capital letter that it's written by it. So that's point P. Just notice you don't see a dot there, but there is a point where those two lines intersect. That's point P. Please don't work ahead on your notes, even if you think you know them. I may want to say something a little bit differently than you might say it. All right, we're moving on. So a line, another undefinable term, and yet look at us trying to define it, right? We're describing it more than defining it. So a line is a set of points. Remember, a point or just a location. So it's a set of a bunch of locations infinitely in two different directions, right? Opposite directions. So this is a representation of a line. This is point R and point S on the line, but there's an infinite number of points that we have not labeled on this line, okay? All the infinite number of points together make up this line. How do we name this any line? We can name it by the lower cursive letter if they've labeled it with a lower cursive letter. So we would call that line L, so with a cursive lower level. And it could be a cursive letter R, it could be a cursive letter T, it could be a cursive letter T. Usually you can tell them. Okay. What do you call the people you work with? Does anybody even have a job yet? A coworker, right? So along the same lines, points on the same line, so people that work at the same job are coworkers. Points that are on the same line are said to be collinear. Brandon, you read what we're writing, buddy? If they're not on the same line, we use the prefix non for not, right? Non-collinear. Oh, I did forget. Thank you. So the other way, so let's, are everybody caught up with me here? Let's go back. I forgot to tell you the other way to name this line. So we're going to name the other way, probably the most common way to name the line is with 2 points on the line, but we have to draw a line above it. So we would write RS and a little miniature line above it. Oh, sorry. Are you guys caught up with me? Okay. So any 2 points, I forget to type this one, there's exactly one line. This is one of those kind of passive obvious statements, but you probably never thought about it. What does that mean? Well, if I've got 2 points and only 2 points, how many lines can I draw through it? I can draw this one. But if I try to go any other way with any other line, there's no way to get those points in there, right? So there's only a unique line between any 2 given points. Now, I can draw more lines through either of the points, but they're not the same line. I mean, it's a different line, right? So any 2 points, there's only one line that can be drawn through that. The intersection of 2 lines is a point. So remember, the dot doesn't make it a point. So where line AB and line BC intersect, that's point E. So point E is the intersection of those 2 lines. Okay. A plane. I feel like of the 3 undefinable terms, plane might be the hardest. So it's kind of like it's a point or like a line. So a plane is made up of infinite number of lines and points. The best way to explain is kind of use a piece of paper, I think. You can imagine this plane, if this paper lies in a plane that extends infinitely in all directions. So it's kind of like a roof that just goes on forever in all directions, right? But of course, a plane can also be vertical or at an angle. So you can't think of it just as a horizontal plane, all right? So also not tangible, just a location, right? So that's why we call it undefinable. It's hard to define, right? It's hard to give an exact definition of that. This is how you'll see a plane represented on paper. Eyes all should be open at this point. Exciting or not, it's hard to learn if your eyes are closed. So this parallelogram here, how they usually represent a plane, all right? A plane can be named in two ways. One way is the capital letter they put in the plane. In this case, that's R, and we're going to say plane R. The other way it can be named, but the line can be named with 2 points and a little image above it, a little line above it. A plane can be named with 3 non-collinear points. So that means any 3 points in the plane, we do not pick 3 points that are on a line. So for instance, they only give us 3 points here, and they are not on the line. So we can name that plane as ABC, and I don't have to put the word plane in front of it. Right? That indicates it is a plane. All right? And just like through any 2 points, there's only 1 line. Through any 3 non-collinear points, there's exactly 1 plane. I have misspelled collinear all through this thing. So just so you know, it needs 2 L's, and I don't think it needs a dash. All right, so points, what do you think points that are on the same plane can be called? Just like coworkers, just like collinear, what do you think they can be called, Aiden? No? No? On the same plane. So points in the same line are collinear, right? People that you work with at the same job are coworkers. What do you think points in the same plane would be? Yep. Nope. That would be coplanar. Coplanar. And points not on the same line then would be non-coplanar. So non means not, right? And where 2 lines intersect at a point, any 2 planes intersect at a line. So plane R and plane P intersect at line H. I can't read that. HI. So line HI is where those 2 intersect. If you can imagine, it's 2 pieces of paper. If I had a ribbon that would slide in that way, the part where they are touching, that's always a line. Okay? So the intersection of 2 planes is at a line. Will you put it for me? As a reminder, I've not graded your notes from the first chapter. I will, and I will grade those very generously. Pretty much, if you have something written for every example, I'm going to give you credit for this. But starting today, these notes, to get credit for them, and I did grade them, it's the easiest grade you can get. But you do have to write everything I write, whether I'm underlining something or circling something. All right, if I make a little note to the side, you need to make the side note. Fair enough? All right, so once again, I haven't graded those other notes. I told you I would, and I will. And I will grade those really easily. But these are going to start being graded a little bit more rigorously. So make sure you write everything I write. All right, space. An endless set of points in all directions. So space includes the points, all lines, all planes. So I don't know why this is not an undefinable term. I kind of feel like it should be as well, right? It's kind of hard. I mean, we are sitting in a space, right? The inside part of this room is a space. Our building is in the Land High School campus. That's a space, right? We can make a space as small, we can define it or restrict it as small or as big as we want, as we need to for the situation. But when we're talking about space and geometry, now we're including all 3D aspects, right? Points, lines, and planes. When drawing 3D dimensional pictures, use dashed lines to represent the parts of the picture you cannot see. So you notice I underlined dash. You guys should underline dash as well. Oh, it says I made it red. That's right. So you're good. What does that the dashed lines mean? So you can see the dashed lines. So this is a rectangular prism, basically a box, right? All the sides of a rectangular prism are rectangle. The part that you can't see, so in this one, it's kind of like this bottom back edge, this bottom corner, and if you're sitting over there, we're thinking that you and JLR, this back side over here, right? So depending on the perspective they give you of the 3D figure, the dotted lines will be in different places. But typically, it's going to be these. All right, so we have to know that those are parts of the figure, but we just can't see them. So when we talk about how many planes are shown in the figure, we can't really see that plane, right? So the rectangular faces of this box represent the plane. So this front of the box, plane D, this rectangle D, C, G, H, is part of a plane. Remember how we name a plane? Three non-collinear points, right? So we can name this plane B, C, G, or C, G, H. Any of those 3 points that aren't in a line, anything with me? Probably warm in that jacket. Okay. So each of the sides of the box are part of a different plane. So how many sides of this box are there? How many sides are in that box? Brandon says 6, and Brandon's right. So there are 6 planes. Each of those sides of that box fall into a different plane. Can you name 3 collinear points? Can you name 3 collinear points, Anthony, from the figure? Can you give me 3 collinear points, so that's 3 points on the same line? Perfect. A, I, and B. That's funny. Most people today have said we're gonna separate them with a comma. So A, I, and B. I saw these 3 first. So either of them will work. So these are 2 options. If it just asks you to name 3, you don't have to give both, but just so you know you have options there on this particular problem. So name 3 coplanar points. Miriam, can you name 3 coplanar points? So coplanar means they have to be fixed. So when they non-collinear, but 3 at the same time. So a plane, kind of like this piece of paper, right? It extends in all directions, right? Sure, Brandon's going to help you. You'll do the second one, though, right? So go ahead, Brandon. S, J, and G. So that's S, J, and G are collinear. They are in the same plane, but they're actually in 2 planes. And that's another reason why we can't use those collinear points. F, J, and G, Brandon's right, it is part of this plane, that end, but it's also part of the bottom plane, right? So only name 3 coplanar points, they can't be 3 in a line. Sophia? DHG. So remember we said that the sides represent the plane, they're part of, the front side is part of a plane. That looks like this, right? The top of the box is part of a plane that goes like this. The bottom of the box is part of the plane down here. So that is, if they spin forever in all directions, those are never going to intersect, right? Both ends are different planes. So can you give me 3 coplanar points? A-E-F would be one, yes. A, E, and F. So there's a bunch of these. I forget what I chose, but I chose D, C, H. So from that front one. So there's a lot. We're not going to list them all. So those are two options for each of those answers. And really, those are the only two options for this one. But if it only asks for three, you don't have to give it twice. All right, so far so good? So when I'm saying 3 points in a planar to a planar, it all makes sense, right? But then, remember, I asked somebody what coplanar meant, and it's like it's a foreign language again, right? If you don't practice it, you don't look back at your notes when you're doing the homework and make sure you know the definition and start recognizing, associating that word with the things that we know about it, it makes it really hard for you to use that vocabulary. So we've got to start practicing it. All right, a line segment is part of a line with two endpoints and all of the points in between. So this line here is going to point P and point Q. That's the line segment. We can't call that a line. Point P and line segment PQ is part of line PQ. It's just a section or a segment. So a segment or a section both mean a part of something, right? So segment PQ means it's a segment of line PQ. Does that make sense to everyone? So we can't find the length of line PQ because it goes down infinitely in both directions, but we can find the length of a segment. The length of a segment is finite. It has a length. How do we name a segment? We name it by its endpoint with a line segment above them. So here this would be PQ, the line segment above it. Could we name it QP with the line segment above it? You can. That order does not matter. You need to stand up, man? If you don't push your eyes again, I'm going to have to do your stand up, okay? And we have to be careful to make sure we indicate the segment by line of race because PQ with no line above it means something different. PQ with no segment above it means they're asking us to find the distance, or they're referring to the distance between those 2 points. How long is segment PQ? So let's put some stars or circle something here. So PQ with no symbol means that if they say find PQ, they're asking us to find the length of PQ. Okay? Array. Array looks like half a line. Right, it's got an endpoint, and then one side goes on forever. It's not half a line. It can't be half because both are infinite, right? So array goes on forever, but only in one direction. A line goes on forever in both directions, right? A line doesn't have endpoints, but array has one endpoint. So this array starts at point P. Point Q and point R also points on the array. But if we're naming this array, we've got to make sure we name it by its endpoint, which in this case is P, and then one other point on the array. And then we got to write a little baby array above it. We can name this array Ray PQ, or we can name this array Ray PR. That doesn't matter, but the order does matter here. P has to be first. So this has to be P, Q, or PR. It does not matter, but we have to put a little array above it, and P has to be first. That is the endpoint. Anytime you see a notation for a segment or an array, we know that that first letter represents the endpoint. Does not matter which way that array is going. The endpoint is the endpoint. So this array is extending infinitely to the left. But when we name this array, we're going to put the B first, point B, point A, and we always draw the array to the right. It doesn't matter, but we always draw that to the right. I don't think you'll ever see it notated with one to the left. Even though this one is pointing to the left, but they can be pointing at all different angles, right? It's not just horizontal, be vertical at an angle or whatever. Questions for me? This is what your homework's going to look like. Classify each figure as a line, ray, or a line segment, then write its name. So they're going to give you a drop-down menu, and you're going to pick, is it a line, array, or a segment? And then in that box, you're going to name it. All right? So is this a line, array, or a segment, Camille? In example 1, is it a line, array, or a segment? Look at your notes. You can see. Which one does it look like? Start at line. Does it look like a line? Yes? Yep. All right, then look at ray. Does it look like a ray? Well, kind of, right? Which one does it look more like? A ray or a line? Yeah, it looks more like a line, right? Does it look more like a line or a segment? A line, right? So that's all we're doing. This is a line, extends in both directions forever. That's what this little arrow is on the ending. So we're going to say it's a line. And there's a little tool. You should name it as, I'm going to name this one PQ just so you know it doesn't matter. And there is a little notation in Alex. You will click. You'll click the box that has that line above it. It may give you options for array above it or options for a segment. You have to know which one to pick, and then you type the letters in. Example 2, Josie, is this a line, a segment, or array? Does it go on forever in both directions? Okay, so we're going to rule out a line. So now is it array or segment? So example 2, is it a line, array, or a segment? Which one does it look like from your notes? Segment. That's okay. So that also is kind of how it is on these segments, right? We think of a line as anything that's just a straight line, right? But we have to go, it's very particular now. A segment and a line are two different things for geometry. And when we name this, we name it with its 2 endpoints, and it's got to have a baby segment above it. It is a U. Kind of looks like a 4 with my bad handwriting, but this board is not the easiest thing to write with or the neatest thing. All right, example 3. Is that array, a line, or a segment? Brandon? Array, very good. Do you know how to name it? No. How do we name it, Aaron? Anything else? The ray above it, yes. If we leave it just RS, that's the length of segment RS. That's how we read that, right? Good job. All right, everybody caught up? Does that make sense, Brandon? Okay, you have to start with the endpoint. All right, so this is how we're representing a plane. This is plane Z, right? In the figure below, points L, J, M, N, and P. L, J, M, N, and T are in plane Z. Points H and K do not lie in plane Z. All that means is these are all on this plane, these two are not. Okay? Is point J on the plane? It is, but the line that goes through that point, it is not. Okay? So now we need to know, how can we name plane Z? Well, we know it's plane Z, that's one way to name it, but we need the other way. Can you name plane Z another way, Jessica? Look at how we name our plane. So this is what our notes are for. They seem very easy when we're taking this, and they are very easy. Right? But it's not so easy to remember every little thing. So that's why we keep our notes out when we start our homework, and we refer to them, right? So did you find how we name a plane? Oh. So it's a capital letter, but that's the one they gave us. So we need this one. So can you give me 3 non-collinear points? Because that's the other way we name a plane. 3 non-collinear points that are part of the plane. Well, look at your directions for the problem. So I'm going to help you. This is, if I work here to help you, it tells you which points are on this plane, right? So all of these points are on the plane. Now the thing you need to tell me, I need 3 of them that aren't on the same line, right? So I need 3 non-collinear points. So you can't tell me M, N, and P because they are collinear. You could use M, N, and T-N, but you need another point, right? You can't use those 3. You know why? Because there's another plane that goes through that line, a different direction. So can you give me 3 letters that we can use to name that plane, Jessica? LJ would be perfect. We could also do N, P, and J, N, M, and L. Right? Any 3 of those 5 points they give us, we just can't pick 3 that are on the same line. Okay? We can use 2 of those and 1 of these others. We can't use all 3 of those. Example 5. Some point and point M are distinct points that are collinear. So point M is here. Collinear means on the same what? The same line. So give me another point on the same line as point M. Billy? N, right? N is fine. We could also use P. Example 6. Point N and 3 other points are distinct points that are coplanar. So I need 3 other points that are coplanar. So L, J, M. We could probably, P, M, J, any of those will work. So let's put L, J, P, but knowing we could also put L, J, M. Does that make sense, Raiden? Okay. Example 7, suppose that line HL is drawn on the figure. It is not the chart, so we can see it as we suppose it. All right, use your imagination at that point that line's actually going through those points. So this is line HL going through point H and point L. It says that line HL and some other line, note the line, if you have a little line indication notation up there, are distinct lines that intersect. What line intersects with HL? What do you think? What line intersects with HL? The Z is not a line. Remember, Z is the name of the plane, right? Chloe, can you tell me? What is the line that intersects line HL? So intersect just means it crosses it, right? David? Not LJ. Well, LJ would intersect that line, but we only have this line on here, right? JK is one way to the line JK, Sophia? Yes, you can name this line either way. So line HK or line JK, like Raymond said, or line HK and JK. Yes, you can reverse on that. Yes, so it's this line here, so it's line HK. Or either they intersect at that point H. Y'all caught up with me? Okay. Do we have more? Oh, nice. Okay. something else. Get out something to write on and something to write with. So get it on paper, or remember, I don't mind using a whiteboard, but you have to have your own dry erase marker. I'm not going to have you turn the word pen. You have to have this on paper out, all right? Now, you may not need it for today, but it might be helpful, like I do that line, so you can see what it intersects with, right? You probably won't use it as much today. Every single day that we do homework, even though I'm not making you print in, I am requiring that you have something to write on and something to write with, and not your notes, okay? Once you have put on paper out or a whiteboard or a dry erase marker at your desk, then you can get your phone out, scan and submit your notes. Once you scan and submit your notes, you can go to Alex. You should go to Alex and find today's assignment. It's AWS 1-2. Remember, once you're done scanning and submitting your notes, your phone should go directly back in your backpack. If you're wearing your phone, I don't want your phone to go in your, if you're wearing your purse, I don't want your phone to go in your purse. I want it to go in your backpack. If you want it to go in your purse, then you got to put your purse on the floor next to your backpack. Remember that the assignments on Alex, you can redo as many times as you want to get a 100, but I do give you the grade, the mastery grade, the percentages that you got correct as your grade for that assignment.